Hello, HCs, receiving students and teachers. Thank you. You may be seated. In our last lesson, we looked at resistance, lesson number 2. And the main things that we looked at in that lesson were short circuit and fuse. Short circuit is caused when electric current takes a shorter path, which results in a lot of current passing through that produces a lot of heat, and that can be very dangerous because it can cause fire, resulting in a lot of damage caused and even lives being lost. But there is a safe way for us to avoid short circuits, and fuses have been introduced. We have found out that fuse is a safety device. The properties that a fuse has is that it has high resistance, and it also has low melting point. So when there is a lot of current passing through, the fuse wires melt, stopping the circuit or electric current to flow. Today's lesson, before we go on to looking at what we will look at in this lesson, I'd like you to look up to the screen. There is a picture for you to look at. And you will tell your friends what is the cause to that picture or what has caused it. Receiving students, if you can talk with your friends, discuss with your friends what you see on the screen. We'll have Paul. Paul, tell us what you see in the picture. Receiving students, you can tell your class or your teacher what you see on the screen.
I see that the front part of the car has been smashed.
Good. What do you think has caused that?
Force that has been applied to the wall. Yeah.
All right. So it's the car and the wall, according to Paul. So he mentioned something about force. There is a force that has been applied between the car and the wall, resulting in the shape of the front of the car. You can see it has been damaged. Our lesson topic for today is force, lesson number 1. In this lesson, these are some of the things that we will do. We will identify the forces used in daily lives. We will demonstrate the direction of forces, and we'll also try to define what force is. The materials that we will need for this lesson are receiving students and teachers. You will work in groups. You will need a ruler, a polyester foam, can be a big one and a small one. You will need magnet bars, a rubber band, and a tenter coin. So these are the things that you will need for today's lesson. First of all, recorders, quickly get these questions down for your groups. You will look at the cartoon, which I will show on the screen soon, and you are asked to find examples of A, pushing forces, B, pulling forces. Recorders, quickly get those questions down. So you will have to list examples of pushing forces and pulling forces. What is doing the pushing or what is doing the pulling? You will also find out which of the examples are forces caused by gravity, or lifting forces, or forces where something bends. And if you can also find examples of electrical forces. So quickly get those questions down. The following cartoon will show how different types of forces are involved in our daily lives. Right? Forces can be found almost everywhere in many different things that we do. So I'd like you to have a look at this cartoon and try to answer those questions with your friends. See if you can find any pulling or pushing forces there. Activities in the cartoon all involves forces. All right, we'll have some students to answer the following questions. Karot. Look at the cartoon. Tell us which of the examples are forces caused by a gravity.
The man in the parachute and the plane up there.
All right, you agree? Yes. You will see that man in the parachute will always come down, all right, because there is a pull of gravity on him. So that's a force there, good. We'll have Anna, you tell us an example of a lifting force.
That person sitting on the little boat trying to get up his fish.
You agree? Yes. Okay. Let's have Edward force applied and something is been bent.
The fishing line.
Fishing line? Fishing rod? Yes? Good. And last one, see if there is any electrical force. Violet.
The lightning.
Lightning? Yes? Yes. Okay, there's some sort of electrical force in there. Good. So you will see in real life situation, there are a lot of forces being applied, and these are some of the examples. Now we will go into our activity. I'll have the runners to come up and get your materials. All right, leave those materials. Do not touch anything. We will go through the activity instructions. You must know what to do before you touch those things. Activity number 1, you will draw a straight path and use one magnet to control the other along it from one point to the other. You are out when you go off the track. This activity, you will not do it in your groups. We will have some students to demonstrate this activity due to the number of magnet bars we have, and then you others observe and record the findings that will be done or demonstrated. That's for activity number 1. There will be some questions for you to answer too. So we will go activity by activity, and you will follow instructions and also do the activity. Your instruction, there is a straight path. In this case, I've used a strip of paper. That's the path that you will follow. You will use 2 magnets and try to let it move along. Control it by moving it along the track. If you go off the track, you are out. You give it to another person to try. So 5 groups come here. These are your magnets. What you will do, you put one on this path, use the other to control it along the track. Group 1 to 5 here. Group 6 to 10. What you will do is you will put one here. Where's the other one? This is your track. You will put one here. You will use the other one. How you do it, as long as it goes on the track to the other. If you go off the track, you're out. Let another person try.
Messi, you are first.
The following questions. You have 3 minutes to answer these questions, so if you can work fast. You got a worksheet. Do your work. Leave this. Complete your work. Answer the questions in your worksheet. Receiving students, you can use the screen. The questions are there. If you find some difficulty in answering the question, please do discuss with your friends. All right, we will go on to activity 2. Your instruction, you will set a target 1 meter away and use a rubber band to shoot the target. You have only 2 chances. So you try 2 times and then you give the rubber band to your friend. You have 2 polyester foams there, one big one. The smaller one can be your target. And you can put it on that bigger one. And then you use the rubber band to shoot. We will go through the questions first. We have 4 questions for you. Activity 3, instruction, you will get a ruler and place it 10 centimeters of the ruler off the edge of the table, and then you will launch a coin from the ruler. How long does the coin stay in mid-air? Right? So that's activity 3, and there are also questions for you to do. So as soon as you finish one question, you move on to the questions, finish it, and you move on to another activity. So you have 10 minutes to complete both activities. You may start now. Now, if you're not clear, I'd like you to look up here. For activity number 2, you will have the polyester foams. The smaller foam will be your target. You will stand away from it about a meter, and then you use the rubber band to shoot. You will have 2 chances before the next person. Third activity, you will have a ruler. Place it out about 10 centimeters off the edge of the table. And you will put the 10 coin and you try to launch this. You may start now. Is this too small? You can use the big one if you want. Now you can use the big one. Shoot the big one. Now what happens with this? What happens with this? Why is that it's moving? Try come up with this. So if you eat it, what happens? Discuss that with your friends. Now, look at this. Why is that this rubber moving from that place to this place? And if you eat this, what's going to happen? Why? Why is that rubber is moving from that place, that point to this point?
Because of the pulling. Yeah. And when you let go,
what kind of force is there? Okay. Now, if you eat this, what happens to this? All these are questions that you've got to answer.
and pushing force.
Now, you have to stand away about a meter. If you knock this out, why is this one falls down? What causes it? What are some of the things involved in there? Okay. Why is it? You discuss it with your friends. Somewhere around there. Now listen. There are some questions and some things that you will have to find out. Why is that this force or this rubber is moving from one place to another? What causes it? Right? Now if you eat that, why is that thing moving? What's involved in there? Okay. You finish this activity, you go straight on to answering the questions. Now you've seen what happens. What has caused the temperature to go right up there, and then it goes down again. What's happening?
The force, when you push the rudder down, the force pushes it up. And it picks up and the gravitational force pulls it down and it goes like that.
All right, most of you have, many of you have completed your activities. We'll have some students to tell the class their findings, what they've discovered or found out. The rest of you should complete all the questions in your worksheets. Receiving students, you should get the questions from the screen and answer them. The first activity, we looked at was magnets. Now, I would like to ask Violet to tell us her findings on that activity. You others can listen.
When we put the magnets, one of the magnets, we pulled it and it dragged the other one. It was attracted to each other, so it moved because there was a force between both of them, and the force was, we could see the movement. We know that there's a force involved because the magnet moved, and the force is magnetic force.
Thank you, Violet. The next activity, we will have the other group to present to us. We'll ask Shane to tell us the next activity on the rubber band target.
When we were using the rubber for target practicing, first we pulled the rubber, it was pulling force there. And when we let the rubber go to hit the target, actually, as it hit the target, it was pushing force, which make the target move.
Thank you. So that's what they found out. We'll have Messi, if you can tell the class your findings on the coin and the ruler.
We put the ruler 10 centimeters away from the table, and when we pushed the ruler down, we applied force. And then when we let go of the ruler, the coin flicked into the air, and then gravity pulled it on again.
Thank you. Before we go on to the summary, I'd like you to get this question done. Define what force is. Now you've tried to carry out activities on force. Now you talk with your friends and come up with an answer defining what force is. Will Jennifer?
I think force occurs when energy is applied.
Very good. Any other definitions? Carol?
We think that force is the pushing and pulling of objects which make them move.
Okay, good. Any others? Dara?
Force is anything that tries to make something move.
She says force is anything that tries to make something move. Very good definitions. All right? I will not dispute that. That's according to your findings. Now, let's move on to our summary. Simple definition for force is a pull or a push. So you will find that forces can start objects to move. They can stop objects from moving. They can speed up, they can slow down, they can turn something, they can cause something to bend or twist, or even they can prevent motion or movement. So force is a pull or a push. There are many different types of forces. There are pushing force. There are pulling forces. Coin dropping, a coin being thrown up in the air. These are examples of how forces move. Rubber band being pushed forward. These are examples. Some forces act by contact, and they are called contact forces. This is when two objects come together, right? Now, in the first part, of this lesson, you have seen a car and the wall. They came into contact, and the result was the front of the car was damaged. There was a contact force in there. Some forces do not need contact and they act at a distance. These are called non-contact forces. Now, magnets, you have seen that even they are some distance apart from each other, but there is some sort of force in between them which try to attract or repel. Our next summary point: force can act upwards, downwards, sideways, or any direction. To show the direction of a force, we can use an arrow. Because we cannot see force, we can use arrow to try to tell which direction the force is going. Why we use arrows is, if I ask a question, when the coin was thrown up in the air, how much force was involved? In these activities we carry out, we cannot actually measure the force. When you pull the rubber band and then you let it go, how much force was involved? Or when you were pulling the magnet. So in those cases, we can use arrows to show the amount of force, whether it's strong or weak. The strength of the force is shown by the length of the arrow. A large arrow means a strong force, and a small arrow means a weak force. We will look at more about this in our next lesson. Our key phrase for today: pull and push. Now, our next lesson is on force, lesson number 2. Following materials received students and teachers. We will bring an average size orange. If you have other fruits, you can bring them. Cake wash soap, 500 grams sugar, drinking cups, dry cell, a spring balance, a beam to end spring balance, and it will also use your worksheets. So those are the materials that we will need. With that, thank you very much, HCs, resident students, and teachers for your participation. You're welcome.